there's a saying that you can't manage what you don't know you have. So once you know very precisely what you have, what condition it is, what's the value of those things, you can make much more informed decisions, both long and short term. The examples that very visual today are the bicycle that we have. The safety of our citizens are of importance to us, and we have implemented a bicycle that's GPS enabled, so we have mobile computers attached to this bicycle. The bicycle and the operator, so our student, will travel 640 kilometers along all of our sidewalks every year. And as he's going, the GPS and the GIS track all the sidewalks that are being inspected. It also identifies all the defects and issues of those sidewalks. So every trip hazard, every defect, all the spalling, all the kinds of issues that you might expect on a sidewalk that might become either a maintenance issue or a safety issue are all recorded electronically, partly automatically and partly manually. All that information is then automatically transferred into our GIS systems. That information is all analyzed based on severity and type of defects. That information then is deployed out to contractors to conduct the repairs, and all those repairs are then tracked back to the original defects. So we know when we identified the issue, the severity of the issue, when it was actually repaired, and the cost of those issues. That allows us to monitor the overall status of our sidewalks, the costs that we're incurring, and to keep the sidewalks safe. Allows us also to mitigate any claims of injury that people may have incurred. Allows us to show that we're doing, in fact, all the things that we can possibly do to keep our sidewalks at a safe level. Information also allows us to give much better long-term planning of what costs are going to incur based on the inventory and the growth on how we need to plan the refund or the revenue required to maintain those sidewalks. That kind of thing we're doing on many different levels, on sewer systems, on road systems, and on the water systems. There's many examples, but that's one specific. We have vehicles that travel the roads doing road patrol. They are equipped with similar kinds of equipment to identify all kinds of road issues, sign issues, debris, any kind of maintenance and repair needs that are out there. So that's deployed out there on the road side of things. We also work very closely with contractors where they use robotic equipment to travel through all of the sewer pipes, both sanitary and storm. They follow a very similar process with that electronic information going to them, coming back to us, and the same kinds of processes are happening there. So it's a fairly wide deployment already. We do expect that we will deploy mobile computing even further out to all of our field staff. At the moment, we have about 10 of our crews equipped with mobile computing, with GIS. They no longer have to refer to large paper maps or large map books. They have all of that information at their fingertips on these mobile devices. We do expect that will deploy to about 45 crews, which is our entire workforce within the next few years. That will allow us to be much more real-time and more dynamic than we ever have been, and certainly improve where we are today even further.
IBM classifies it's smarter as a result of taking advantage of the increased amount of instrumentation that's around the world. So when we talk about wastewater management system, traffic management systems, etc., there's an increasing proliferation of sensors. Those sensors provide the opportunity to create and capture information that's communicated up to their maintenance and management systems. As a result of that, they can dynamically deploy resources from the city in order to respond to the associated infrastructure challenges that they've got. So in the simple example of wastewater management system, they can manage capacity flow to achieve a sustainability objective. That says how much are we consuming, how much are we using, how much are we taking off rainfall and land water, and what are we doing in order to assure sustainability, as well as leveraging that information to get predictive about their maintenance schedules and management of that infrastructure to avoid costs long term. So this gives this information integrated into their existing platform for IBM Tivoli Maximo, as well as a number of other different third-party capabilities that integrate GPS as well as GIS or spatial technologies, allows them to dynamically respond to the infrastructure demands of their city because they're taking advantage of the sensor and the inputs that are throughout their infrastructure, take advantage of that information and dynamically respond to the challenges that their city faces.